going to look at 2012, the June paper. Got two questions to look at, 4b and question 7. 4b, a fishing lake is initially stocked with 100 fish. 1,000 fish. It's estimated that 20% are caught or die. So year 1, they will lose 20%, so you'll only have 80% or 0.80 times 1,000. It is restocked with 100 fish. So if you work out year 1, you'll get an answer of 900. It then says work out year 1, year 2, year 3. So year 2 is 0.8 of what was in year 1 plus the extra 100. So I'm always looking for patterns when I'm doing these kinds of sums. Plus 0.8 times 100, so I'm in a bracket, plus 100, which gives you an answer of 820. Year 3 is 80% again of what you had in year 2. Again, I'm trying to look for patterns. Just writing this out, which gives you an answer of 0.83 times 1,000 plus 0.82 times 100 plus 0.8 times 100, giving you an answer of 759. Then it says these are the first 3 terms of a sequence. Find a recurrence relation for the sequence. So part 2. To find the next term, I'm always taking the previous term, finding 80% of it, then adding 100. The initial value that was in the lake at the beginning was 1,000. So that's the recurrence relation written out. Part 3, find the limit to which it converges. Now this is quite a strange one and quite a tricky one to do. So here is my wee relationship. Basically I want to see what does it converge to, which means what's the last term. Now the last term and the one before it will be pretty much the same because it's converging, it's getting smaller each time. So if you just write the last term is L and the one before it is L, bring this across and take it away. So it's 1L, take away 0.8L, bring your 0.2 over, and you'll find that the last term is 500. Now, the next question I'm going to look at in this paper is question 7. So it's a GP, and the sum of the first and the fourth is 560. So question 7, it's a GP. So UN is AR M minus 1. And I'm told that the first plus the fourth equaled 560. So let me do something with that. The first term is obviously A. The fourth term is N equals 4. So it's AR3 equals 550. If we go back to the question, you're told there that the sum of the third and the sixth terms is 1260. So the third plus the sixth is 1260. So let's just plug that in here. So the third term is AR 3 minus 1, so AR squared. The sixth term is AR 5 equals 1260. Call this equation 1 and equation 2. I'm going to put equation 2 over equation 1. But what I'm going to do is I'm going to factorise out this A and the R squared. So I'm left with 1 plus R3 equals 1260. And if you look at the first term, I'm going to factorise, or the first equation, I'm going to factorise out the A. That means those brackets cancel off, the A's cancel off, leaving you R squared equals these two here. So if you cancel those down in the calculator, you get 9 over 3. So R is plus or minus 3 over 2. Remember always to find plus or minus at A level. So the question said find the possible values of the common ratio. We've done that. We're now told in part B, the sum to infinity of a different GP is 5 times its first term. So let's get that one sorted out. So part B, the sum to infinity is 5 times the first term. The sum to infinity is A over 1 minus R, so it's 5A. Just bring that 1 minus R to the other side. A's cancel off. 1 over 5 equals 1 minus R. So moving that around, R is 1 minus a fifth, so R is 4/5.